This video is all about how we describe reflections. So at the top of the board, I've put some starting points for you to think about when you're trying to describe a transformation. So if you're describing a reflection, the mirror line is a line upon which you're going to fold your grid up so that the image lies directly on top of the object. Now, I can't physically do this without actually drawing a piece of paper and doing it. So we're going to have to see if we can do it by using our imagination. And the other point I've put is about whether the reflection or the mirror line is a vertical mirror line, whether it's a horizontal mirror line, or whether it's a diagonal mirror line. And what you look for is you look at what's happened to the shape. So if you see the shape has flipped vertically, so that as the top has become the bottom and the bottom has become the top of the shape, but left and right have stayed the same, then it will be a horizontal mirror line. If the shape has flipped horizontally, so everything that was pointing to the left is now pointing to the right, but the top and the bottom have stayed the same, then that means it's a vertical mirror line. If everything has swapped, so the vertical lines become horizontal and the horizontal lines become vertical, then we've got a diagonal mirror line. Now these are the ones that are particularly difficult for us to address, okay? So if you can do them already, that's pretty awesome. Right, so what I've got on the grid at the bottom here is some different transformations. Now I've tried to shade the shape that we're starting with as our object. So here you can see the orange shape is our starting shape for each of these 4 different transformations. So if we look at number 1, we can see that this R shape has been flipped so that it's now an L shape. So the top of the R is now the bottom of the L. So we can see that our shape is effectively flipped in that direction. So if I was to fold this board in half, we would have a horizontal mirror line. And as we were doing our transformations earlier in the week, we said that the mirror line must be equidistant. So if I was to fold in half, I think our mirror line is going to be along this line here. Okay, and so if you look, the point at the bottom underneath the mirror line to here is 2 squares below. The original point on the object was 2 squares above. So we're quite confident that that's our mirror line. So if I wanted to describe that mirror line, this is the line when the y coordinates of each of these points is always 1, because you can see we've got 1 on the grid. So that's the line y equals 1. Now we should always state it's a reflection. I know that's all we're dealing with at the moment, but when we start to look at all the different types of transformations, we should state what that transformation is. So I've written reflection in each of these descriptions because that's a really important fact when you're trying to describe what transformation has taken place. This next transformation, then we'll look at number 2. So you can see that what's happened here is that the R has been flipped left to right now, which means that the mirror line, if I was to try and fold that grid in half somewhere, the mirror line would be vertical. And again, same word I used earlier, equidistant. The distance between the points on the object and the image should be of equal distance. I'm going to just draw my mirror line on there, and it's somewhere down there now. Obviously that line goes all the way through the grid. And if you look, this top corner here on my image is the same as that top corner there. And it's 2 squares away to the right, and the original point was 2 squares away to the left. So I'm quite confident that that is my mirror line, this line here, and the description of this mirror line is all of the x coordinates along this line have a coordinate of 1. So this is the line x is always 1, or x equals 1. Right, on to the really tricky ones now. So we've got 2 transformations here, which we can hopefully see are diagonals, because what's happened here is that we haven't flipped left to right or top to bottom. We've flipped vertical to horizontal. So if you look, this line across here is now that line there. And so you can see that our reflection line is going to be where we're folding that so it lies on top of it. And hopefully we can draw that on. I think the mirror line is going to go somewhere down there. Then we have to figure out the equation of that line, which is really quite difficult. But we can see where it crosses the y-axis intercept. So we're going to use the straight line equation y equals mx plus c. And this is our y-axis intercept. And this is what we're going to refer to as our gradient. Now, for the purpose of all of our transformations on a grid using diagonal lines, we're just going to use simple diagonal lines which have a gradient of +1, which is a positive gradient, or -1, which is a negative gradient, because it gets very, very difficult if we don't use those two diagonal lines. So this line has a negative gradient because if you go across a step of 1 to the right, you go down a step of 1. So the gradient is -1. Now we don't write -1x in straight line equations because in algebra we tend not to write 1 of something. So we're going to say that that's the line y equals -x because it's got a gradient of -1, which is the m value, and it's a +5 as to where it crosses the y-axis. Now that's beyond your capabilities at the moment. Don't worry about that because it is really, really difficult stuff. That. Same for number 4 then. So this time it's been inverted. I think it's been inverted that way. So if you think about it, this length here has gone to that length there. And so if I was to chop that in half, I believe there is my reflection line. So if I'm trying to figure out the equation of this line using the same straight line equation from before, crosses at 4, so we've got a +4 on the end. And this time, if you take a step to the right of 1, we're going to go up a step of 1 to find our gradient. So this time it's got a gradient of +1. So that's just going to be x. So we don't need to write the 1 in there because the 1 of x is just written as x. And so what we've got here is some really difficult straight line equation stuff where we're figuring it out. Now, what I want you to do is be able to put the mirror lines on, and some of you to have a go at trying to describe these mirror lines.